Swayam Prabha. Digital India. Educated India.
Other properties, specific gravity is 2.7 and melting point is 658 degrees Celsius. Pure aluminum is very soft and ductile. Okay, so that is again why it is not always preferred for structural applications. What are the alloying elements? Typically you put copper, magnesium, silicon, manganese for increasing the strength and hardness. And another way to enhance the properties is anodizing the aluminum, which is used for cast fittings, grills, extruded sections for frame, doors, windows, partition walls. So you can notice this, all these are really non-structural elements. Okay, they are not part of the major beams and columns in a building. Okay. So I will just show you how this anodizing is being done. Okay, what is this? This is a process of coating of the aluminum with a thick layer of aluminum oxide. Okay. So how is it done? By dipping the aluminum in a diluted or weak sulfuric acid bath. What you see here, this is the sulfuric acid bath. Okay, H2SO4 bath. Then you have, this is aluminum, okay, and this is a cathode here and aluminum is the anode. Okay. Okay. So a low direct current or low DC current is releases the hydrogen at the cathode. It releases the hydrogen at the cathode, hydrogen is coming out, and it releases the oxygen at the surface of the aluminum anode, and which is the positive electrode. So what happens eventually is the aluminum oxide is formed at the aluminum surface. Okay. Now creating a built-up of a transparent, porous, abrasion resistant, corrosion resistant and non-conductive aluminum oxide. So there are so many properties for this aluminum oxide. Okay, or this is what we call as anodized aluminum. And to provide color, like you see on the right side, there is a keychain with the blue and red color, that is achieved by using some dyes. Okay, coloring dyes or pigments can be deposited on the fresh anodized surface. I will show you how it is done. Okay, so you can see here, this is a yellow shaped, you can see here this element, it is yellow color. That is because they used a dye which has yellow color, and this is the, you can see here, it is a zinc bath at the bottom of that. You can see here also there is a zinc bath into which this is dipped, sorry, not zinc bath, I am sorry, it is a sulfuric acid bath into which it is dipped, and then after that it is cleaned and all those processes, this is essentially the cleaning process going on. Okay. Now, how the anodized aluminum is made or how is it enhanced, that it is ensured that there is a good resistance both in terms of hardness also, and then also we need some kind of pockets for the dyes to occupy the space so that it gives color to it. So what we do is, first the process is you take a silicon carbide, mold. The reason is it has this this protrusions on that. Okay. Now when this is pressed against the aluminum plate, what will happen is there will be indentations formed on this. Okay. So you are essentially making a uniform structure with indentations, and then you grow the aluminum oxide on that surface. So this is the aluminum oxide which is grown, okay, by applying current to it. This is that oxide layer, okay, the white thing. So you have this oxide layer formed. Now then you have how the mixing process or the movement of the the dipping elements or the anodes in the solution, or the fluid, the flow of the solution around this thing, and the temperature of the solution play a key role in forming this oxide layers. So eventually what you get it, you can look at this. This is the oxide layer or the U-shaped layer which is formed. It is a microscopic scale, okay, and then inside that you have metal deposits, or which is basically giving you the color also, okay, and then in a rather 3D scale view, it will look something like this. So you have this U-shaped pocket. So honeycomb structure, very similar to a honeycomb cell structure with a hollow core called a pore, and in that pore you will fill the coloring coloring pigments, etc. But now the relationship between the cell wall size and the properties. So the cell wall size and the pore size can be controlled mainly by by temperature and mixing of the solution or agitation. Now while large cells with small pores are stronger and protect the surface better, but do not take the dye as well. In other words, large cells, so let us say I am going with a cell like this, okay, and let us say I have a pore like this, okay, oops. This is one case, assume, okay, and another case is small pore but large pore volume, okay. So these are the two cases we are talking. Large cells with small pores, that is this case here, are stronger and protect the surface better, okay, but they don't take the dye as well, means there is no space for the dye to be occupied. Whereas the large pores with thinner cell walls, so this is the thinner cell wall, that means the pore size is larger and they will take the dye better, but don't protect the aluminum as well from the physical abuse. So you will have a lot of damage or abrasion, those kind of problems could be there. So essentially when you talk about longevity, etc., it's a balancing act. You have to kind of adjust the size of the pore size and size of the cell wall thickness, etc., have to be adjusted so that you get optimized properties. Now on the bottom right, what you see is a micrograph of surface, anodized surface, showing ideally ordered pores on the left half. You can see here on the left half of the drawing you have an ordered structure, whereas on the right half you have a random distribution, okay. So these are all manufacturing procedures or the anodizing procedures. Now what is the advantage of doing this anodizing? You can see that anodized aluminum is the one with the red curve here, and another typical aluminum with the 1100. So the range, the properties, how it can change, and mild steel is somewhere here and hardened steel here. So the hardness, so this property is where essentially looking at the wear cycles. So basically it is looking at abrasion resistance or hardness, how resistive, not hardness necessarily, how resistive the material is against abrasion. So it is looking at wearing cycle. So as a function of wearing cycle, what is the thickness? So if you look at the horizontal axis, let us say I am going to look at here, let us say 0.005, let us take this point, okay. At a thickness of 0.005, that much material, it takes how many wearing cycles for that to lose, okay. So in case of an aluminum, almost nothing. This is where the aluminum, it's right here. And then in case of a mild steel, maybe this is here. In case of hardened mild steel, you can see it is somewhere here. And in case of hard anodized aluminum, it is somewhere here. So that's the huge difference you can see. How many extra or additional, like that's about 60 cycles were required to to remove that the thickness loss which is looking at. Okay. So, definitely when you use the anodized aluminum, you have a very excellent surface property. So, the aluminum with anodization or anodized aluminum will have very good wear resistant, or rather abrasion resistant. I mean, it can be related to that also, if not directly, and that means hardness is also very good. Okay. Now, let us look at difference between, this is electroplating, you might have heard about this in your earlier schooling, right. So, let us see the difference between electroplating and anodizing. What is electroplating? Electroplating is essentially coating of a different metal to the surface. Okay. So, if this is the on the top right, you can see, if this is the metal which you want to coat, we are in this particular example, copper is coated onto the metal which need to be protected. Okay. So, any metal Me can be coated with copper. That is the way by which when we talk about electroplating, that means that. In case of anodizing, what it means is coating of the same oxide, okay, coating of metals with tightly adhering oxide of the same metal. That is the difference. Okay. So, in the case of electroplating, one metal is coated onto the another metal. In case of anodizing, a metal oxide is coated to that same metal. Okay. So, this is the main difference, and when you do this metal oxide coating, then you change the corrosion properties because its electrical resistivity etc. changes, and then you also change that depends on the property of the oxide layer, but essentially you get a hard surface etc., hard and corrosion resistant surface. Now, where do we use aluminum? Okay, aluminum foil can be used to insulate building, even though not much used in our country, but if you go abroad you will see that this is widely used in many of the building construction. Okay, mainly because it has this reflection, it reflects the heat from the heat energy, radiant energy, and up to 97% of the radiant energy can be reflected back if you use aluminum foil. Okay. What does it composed of? You can see, as you see in this picture here, two outer layers of aluminum foil and an inner layer of some inert material. So, it is like a sandwich material, a sandwich product, and typically this inner layer is made of some kind of plastic, polyethylene plastic, fiberglass etc. To create, the main purpose is to create an insulating air layer in between. So, you have an aluminum layer, some air layer with some bubbles etc. The purpose of this fiberglass or polythene is to create that space in between the two aluminum layers. Okay. So, that will provide a lot of resistance against the heat across that layer. Now, here is an example to show. You can see here on the left side, can you see this box here? There is a box like structure here, and here also you can see a box. Okay, and inside so this temperature is a fiberglass is ineffective at stopping radiant heat, but the reflective foil redirects the intense rays from the heat lamp, keeps the chamber cool at 78 degrees Celsius. So, on the left side you can see that it has aluminum foil, and then there is a bulb on top outside, and then they are measuring the temperature inside the box. Okay. So, in the left case where it is covered with aluminum foil, that even though the high heat from the bulb, it is not able to penetrate into the box, whereas on the right side you can see 107 degrees Celsius, okay, on the right side. So, very clearly aluminum foil can prevent the entry of heat. So, on the right side you can see a picture, on this picture on the bottom right, it is a part of a structural structure or a building where you can see a column and a beam structure there and the wall element. So, the wall element is is actually they are providing an aluminum foil on the wall element, so that the heat does not enter into the building through that wall element. Now, aluminum is also used for formwork because it is lightweight, it is easy for people to carry, the workers to carry, etc. So, widely used for concrete construction also. So, aluminum formworks are nowadays used for getting nicely finished exposed concrete surfaces. Okay. Now, let us look at the next metal, that is copper. Copper production worldwide, if you look at, India is not a major producer. Okay. The top producer is Chile, okay, then China, then Peru. So, Chile is about 32%, China, all others included is like a 14. So, the next player is China, which is about 9%, okay, Peru 8%, so more or less very not big difference, but Chile really outperform everyone else, probably because of the raw material availability in that country. Okay. Okay. Now, for making copper, mainly the oxide and sulfide ores, these are the main ores which are used for the production of copper, and these ores typically contain about 0.5 to 2% of copper. So, just very little, 0.5 to 2% of copper. So, you have a lot of material to be processed and lot of waste will be generated, and then and what are the typical ores? This chalcocite and chalcopyrite and then covellite. So, these are the typical ores which are which are being used, and about 80% of the global copper production is from the sulfide source. So, this is the main copper ore which is used. What the picture I showed on the right side is from typically, like in the case of steel production or iron, you have billets. So, like that in the case of copper, they typically produce this kind of rods, large diameter rods, and which is used for further production of wires, etc. Okay, that is probably why that shape is still maintained at circle. I do not know, but I am guessing it that way. Okay. Now, copper and its alloys, because of high resistance against corrosion, atmospheric corrosion, high resistance against atmospheric corrosion, copper is used in buildings along the coastal regions, and also wherever there is a corrosivity is high, copper is actually used. Now, traditionally used in temples, roof elements of temples, and then also ships, sheathing for the hull. So, this protects the hull from getting into direct contact with the seawater, etc. So, on the left side you can see a temple roof in Kerala, because in Kerala you have many temples are like this, which has this copper cladded roofs. Okay. And then this is another close up of this, how it will look like. So, mainly wherever you have a highly corrosive environment, copper is a good metal to use. Now, this is a couple of examples where the corrosion product of the copper is used for the aesthetic appearance. You can see here, this is a embassy building, Nordic embassy in Berlin, Germany, where these are all copper clad, the walls, sunshades, etc. are all cladded with copper sheets, and the green color which you see is actually the corrosion product of the copper, okay, the patina or the oxide layer of copper, bronze, I mean all these have this green color, right. And Statue of Liberty, this one, the color is not really the paint, it is the oxide of the copper, and then let it be there. This is a natural color, it will not fade away, etc. So, and you have to just see the beauty of that, but this one here, it is not really good because it is a pipes when they start corroding, but I am just trying to show you that if you have copper pipes, you might see this green color rust on top of that. Okay. Now, what are the alloys? There are two major alloys, one is brass and the other one is bronze. Okay. So, this copper is used in electrical cables, plumbing. You can see the photograph showing different applications of copper, and the alloys are one brass, which is an alloy of copper and zinc. The bronze is the alloy of copper and tin, okay, Zn, and this is Sn. Okay. Now, these are generally like a stronger than copper, that is why they go for this alloying process, and can be cast into different molds or whatever shape you want, and brass fittings are used extensively for doors or window fittings. I mean, it also has this golden color, so people like it, aesthetic purpose with the teak wood or in a wooden, it matches nicely, and then it's really shiny also. So, you can see this difference between brass and bronze. Very difficult sometimes to really notice the difference, but just to give you a sample to look at. Now, advantages and disadvantages of copper pipe or plumbing. Let us look at advantages first. Okay, relatively soft metal. So, it is easy to bend and cut. Let us say you are talking about a plumbing work. If you have very rigid in which you cannot bend, or slight adjustment etc. are not possible, then the workers may not like to work with it, or the workability. I mean, if you want to relate to cement, concrete etc., but it's easier to bend, cut to a particular size and shape, whatever you want to do, it's easy to work with. So, workers will prefer to use this kind of pipe rather than a steel pipe, which is very difficult to cut and work with. Now, bacterial growth is less than that in the plastic pipes. If you have PVC pipes or other plastic pipes, then you will see that after some time there are slimy layer formation etc. on inside the pipe, and which is less in case of copper pipes. And also it is very resistant to corrosion. So, that means durability is very good, and it is UV resistance, whereas if you look at the PVC or PVC pipes or other plastic pipes, they might not be UV resistant, or not. UV means ultraviolet, and after some times those plastics will become brittle, but whereas in case of copper you do not have to worry about such problems. Okay. Now, then less temperature induced variation. Even if there is a fire attack or something, if you have plastic pipes etc., they will melt and then get damaged, but copper pipes will stay intact for relatively higher temperature. Now, no release of toxic gases. If there is a fire etc., if you have PVC pipes etc., all that will burn, and that means a lot of toxic gas will come out, will be released. But in case of copper pipe, again you do not have to worry about such toxic gases. And copper being a metal is easy to recycle and reuse for making the same thing. But if you have plastics, and especially if you have a thermoset plastics, then you cannot really reuse those kind of plastics. So, that also adds value to the sustainability option, so you can actually recycle the copper pipes. Now, one disadvantage of copper pipe is associated with the pH. See, in most of our cities, sometimes the pH value of the water which you get, I have seen places where pH value of the water is less than 6.5. Okay. So, so you have to see, if that is a condition, copper pipe may not be a good option to go for. So, you have to see what is the type of solution or water which is going through the copper pipe, or where it is being placed, whether the pH environment to which the copper pipe is exposed should be in between this range, then only it is good, otherwise it will not be good, it will be harmful. Okay. And other major problem is it's because it's very expensive, people tend to steal it away, or vandalism is a big problem, but that is a non-technical problem. We have to work around the system to counter that. Okay. So, to summarize today's lecture, we talked about production, properties and uses of aluminum, and also production, properties and uses of copper, especially in the civil engineering or construction sector. Thank you.